In this video, I'm going to go over how to solve trigonometric equations, and we're going to be using a lot of the information and stuff we've been working at basically since the beginning of this semester. Okay, so a reminder about sine and cosine, right? The period for both of these functions is 2 pi, and so sometimes it's going to ask you to find all of the possible solutions, and so we can't just keep going around clockwise and counterclockwise forever. So we put plus or minus 2 pi times some integer, and I'll explain how to find that based on the work that we do in these solutions. So let me give you an example with this first one, cosine. All right, so it says find all possible exact solutions for the equation cosine of theta equals 1/2. So what we're going to do is do cosine of theta equals 1/2. All right, and this is actually very similar to the work that we did in the last unit on going backwards, right, doing the inverse function. So essentially what I'm doing is I need to ask the calculator, okay, I know the ratio is 1/2. So if I go backwards and tell you that it's 1/2, what would be my theta? And so you should know this one, right? This one is from the table. The cosine of pi over 3 is going to be that theta. But because it says all possible solutions, we don't just stop there. So what I'm going to do is I'm just going to do a quick little sketch, all right? So I'm looking for where cosine is positive 1/2. That's from this isolation of the beginning. I know it was the actual equation, but you'll see later on this is that point where we've isolated our trig function. So in the first quadrant, that's going to be here. We already know that's pi over 3. Okay, we found that one. And cosine is also positive in the fourth quadrant, right? The last quadrant. So if you remember how to find that, right, all the way around is 2 pi, and we back up that reference angle of pi over 3. So you're subtracting 2 pi minus pi over 3, which is going to give you 5 pi over 3. All right, so these are the two solutions I'm going to write, but because we can keep going in a circle in one revolution either direction, counterclockwise or clockwise, I'm going to put plus or minus, all right, and I'm going to put 2 pi k, where k is how many rotations you want. So if you want k to be 1, that would mean you're going to go around one time. If you want k to be 2, you're going around twice. So the other answer, I'll kind of write it, let me write it over here, all right, would also be 5 pi over 3 plus or minus 2 pi k. All right, so again, these two are both the solutions, and because it wants all of the possible solutions, we have to throw in that plus or minus 2 pi k. All right, let's go to the next one. It says find all, again, possible exact solutions for the equation sine of t, theta, whatever it is, equals 1/2. All right, so I'm going to write it down. Now, again, this is already isolated, right? Don't have anything in front of the sign or behind the sign. So very similar to what I just did. I'm going to go sine to the negative first power of 1/2 equals t. And again, I'm hopeful that we know this one. The sine of pi over 6 is 1/2. All right, so this is one of my solutions. But again, because we're talking about all solutions, we have positive pi over 6. And sine, right, just like we did before, it says where sine is positive 1/2. So if I'm thinking all students take classes, sine is also positive in the second quadrant. So again, how you find this is that's pi. We back up the pi over 6. So pi minus pi over 6 is going to be 5 pi over 6. That's stuff that we did in the first unit. Okay? So you write down these two solutions. So pi over 6 and then 5 pi over 6. All right, but we write plus or minus 2 pi k because I don't know which direction you're going to go around the circle, clockwise or counterclockwise. And also, I don't know how many times you want to go around the circle, so that would be that integer k. So that's what we do to solve these equations when it says find all possible solutions. Okay? Now, let's go to the next one. Now it's going to narrow down for us, which is kind of nice. Don't have to find, all of them. So this part at the very end tells you that we're trying to find our thetas between 0 and 2 pi. All right, so essentially I'm going to isolate, so 2 cosine theta minus 3 equals negative 5. Let's isolate cosine of theta. All right, so move over the minus 3 by adding 3. So negative 5 plus 3 is negative 2. Move over the 2 that's in front of the cosine by dividing by 2. Negative 2 divided by 2 is going to be negative 1. All right, so now I'm trying to figure out, all right, so if I do cosine to the negative first power of -1, this is going to give me my theta. And I know this can be tough, right? Here it's isolated. And when I read that, because I'm thinking about my table of values that I have memorized, the only one that I see 1 in my table is for tangent. So when I see cosine or even sine with a 1, a -1, or a 0, I'm thinking quadrantals. All right, so I know it's been a while since we've had to do this, but make sure you don't forget that quadrantals are never going to leave us. So we have 0, this is pi over 2, pi, 3 pi over 2, and all the way around is 2 pi. And we're looking for the ordered pairs. So this ordered pair is 1, 0, 0, 1, -1, 0, and 0, -1. Okay? Don't forget this is going to be cosine. This is going to be sine. So we're looking where is cosine -1. So the only place where the x-coordinate is -1 is at pi. So our solution, based on the quadrantals for theta, is going to be pi. And we don't have to put plus or minus 2 pi k because it tells us, like I mentioned here, that theta is between 0 and 2 pi. So that's why the answer is just pi. All right, another one kind of similar to that. Again, it tells us we're going between 0 and 2 pi. So let's move the positive 1 over with subtraction. 0 minus 1 is -1. Let's move the 2 over with division, and we get -1/2. All right, so now watch, this is different. We haven't done this yet. All right, we've isolated our trig function. So I'm going to write sine to the negative first power of positive 1/2. Notice I know it says negative, but I know that's -1/2. I'm putting positive to find what we call our reference angle, okay? So hopefully you know from your table the sine of pi over 6 is 1/2. All right, so I'm not saying the answer is pi over 6. I'm saying my reference angle is, and I need to try to figure out where in my quadrants is sine going to be negative. So I'm looking here. Where is sine? Oops, sorry, that's not what I wanted to do. Let's get that over. There we go. I'm looking here where sine says it's equal to -1/2. And when I think of all students take classes, sine is going to be negative in the third quadrant and in the fourth quadrant. All right, so this is pi. This is 2 pi. So I'm going to be adding my reference angle to pi and then subtracting my reference angle from 2 pi. So my two answers will be pi plus pi over 6, and my other one will be 2 pi minus pi over 6. Get a common denominator, and you get 7 pi over 6. And for this one, we're going to get 11 pi over 6. So again, it's one of those things where we're using so much of the basics that you learned in the first unit to help us solve these trigonometric equations. Okay? All right. Let's solve some where they give you reciprocals. All right. So again, I'm not that concerned. Like, I remember the work that we've done with reciprocals. So I'm hoping when you see cosecant already here, cosecant of theta equals -2, right, that you should change this to be the reciprocal of cosecant, which is sine, right? But now, because I've flipped essentially cosecant to be sine, I need to do the reciprocal of -2. And the reciprocal of -2 is still negative, right? We don't change that. But the reciprocal of 2 is 1/2. So it actually looks very similar now to what we did on the last problem. So I have sine to the negative first power. Again, I drop the negative to find the reference angle. The reference angle is pi over 6. And I'm trying to find in my, go right here, on my quadrants, where is sine going to be negative? And just like before, sine is going to be negative in the third quadrant and the fourth quadrant. So it's actually exactly the same as what we just did. We're going to add the reference angle to pi, and we're going to subtract the reference angle from 2 pi. So that gives me two of my solutions. So pi plus pi over 6 and 2 pi minus pi over 6. So we get the same ones we just got, 7 pi over 6 and 11 pi over 6. But I don't know if you saw this, kind of just breeze right by it. It says for thetas between 0 and 4 pi. So now we've got to go around the circle another time. all right? Because another 2 pi plus 2 pi would give us the 4 pi. So another theta is going to be our 7 pi over 6 answer plus 2 pi. And our last one is going to be our 11 pi over 6 answer plus 2 pi. So actually we get 4 solutions here. Changing 2 pi to have a denominator of 6 is 12 pi over 6. So when you add that together, you get 19 pi over 6. And then 11 pi over 6 plus 12 pi over 6 is 23 pi over 6. We actually get 4 different solutions here for theta. All right, that was pretty, probably a little confusing since you've never done that before, but that's what I mentioned earlier about depending on what they say, you might have to go further around the actual quadrants. Okay, let's do one.